Thank you for being here. I'll be brief because I know we're all freezing and starving. Like the previous speaker, I will also be showing you some of the projects that we are working on. Some are finished, some are in progress, and there's a little bit of everything. But I will not be focusing on technology. I'll be focusing on visualizing ideas. And, there is an art and a science and a craft and a technique to visualizing concepts and ideas and emotions. And it's really not about the technology. It's about the project. All right, so we use animation at EOS, at the Earth Observatory, to visualize. And wow, this is so small here. I guess it's better for me to look at the screen. And we use it to visualize all kinds of things. And part of the science communication work that we do there has to do not only with presenting scientific concepts in an objective mathematical way, but also making people, average people who are not scientists, who might live in hazardous areas, understand what the concepts are about. So we find that there's many different ways to use animation. Sometimes we use it to teach concepts, sometimes we use it to explain or to tell a story. And I'll be showing you a few projects to illustrate those different types of uses. We believe that it's very important to inspire audiences. So when we present visualizations that have to do with scientific concepts, we believe that unless we're inspiring somebody and entertaining them, the next two concepts don't happen. So if you just lecture people with a wonderful technology in between, it's not going to work. You need to convey information that is inspiring and entertaining, and then everything else might happen, which is inform and hopefully transform how they live their lives. You can find a lot of what we do at the Earth Observatory website, which is earthobservatory.sg or art-science-media.com. So here we go. So EarthGirl is an app that shows people how to survive tsunamis, basically. It's a free download from the App Store or Google Play. We have translated it to many languages. It's online. We just published this week version 2 of most of the versions. And we have used it to teach people, mostly kids in Indonesia, how to prepare for tsunamis. 2 years ago, we started using it at NTU, a natural hazards undergraduate course that you see has a lot of people. And basically, this is a casual strategy that allows you to play pretty entertaining levels with very realistic scenarios and a simulation engine that simulates earthquakes and simulates what happens before and during the tsunami. And you get to test your abilities, and in this case we have students compete with one another and see who can save the most villagers. So check it out, it's a free download, mostly for tablets, but it also runs on large screen Android phones. Merapi Interactive is a project that where we are hoping to explore volcanology concepts through cultural references. Merapi is a volcano near Jakarta. Merapi has a deep cultural significance in Javanese culture. So we have tried all kinds of, we hope, original ways to, who's playing? Yes, who's playing? All kinds of ways to convey different aspects of the volcano. So this is based on a painting by Salen Rade, who's a very famous, I believe, 19th century Indonesian painter who did 2 paintings of Merapi. One is a day eruption. Actually, I believe it's at the National Gallery here. And so we took that painting, which is just one still about there, where the pyroclastic flow is in the middle, and we animated the whole thing. This is part of a website, an interactive app that we're building to teach people about volcanic hazards. It's really centered on Merapi. So there's a lot of cultural issues here. This is a slightly more scientific cross-section of the Earth that shows you the dynamics of a volcanic eruption in Merapi. And one of the things that scientists at EOS have confirmed in recent years is that Merapi has 2 volcanic deposits, and that is one of the reasons why it's so explosive when it erupts. And they also use all kinds of clues, like these things called amphiboles, which are some crystals that are created deep down in the magma and float up to the surface. So we try to visualize all these pretty technical concepts in the most artistic possible way. So we mix all kinds of techniques, of artistic techniques. I think it stopped. It's not supposed to stop. Oh, maybe I shortened it. We use 3D, we use 2D, we use painting, because the main objective is to communicate how this thing works. All right. The Rat River Expedition is a movie about earthquakes in Nepal that we created with the objective of actually informing and teaching people in Nepal about the hazards that exist around and under their homes. So one of our goals from the beginning was not only to showcase the work of EOS scientists, which is really innovative and interesting, but also to, at the end of the process, reach out to the community there and have them see the movie. So our challenge was, how do we visualize these very technical concepts, some of them groundbreaking science, to people who have never heard of, earth science before, and they don't really know what an earthquake is or why it happens. So, much to our surprise and delight, after we did the 1-week online preview of the movie in Nepali, we got 79,000 likes in our Facebook page, which we thought was really incredible, because we had never done this before at EOS, and because we didn't know of too many people who have done this in the first place, and because so many people, mostly teenagers, people who work at home, people who work and then come back home and look at their phones, looked at it, and so this for us was really a proof that social media really works if you know how to navigate through it. One of our challenges in visualizing things when we make films or games is that we usually start with diagrams like this, which are very packed with information, and they are kind of technical looking. There's a lot of information in here, but if you're not an earth scientist, it'll take you 5 minutes to really decode and understand what's in here, and unless you have context and previous knowledge, you're not going to get everything that's on this diagram. So our job in visualizing this information for a mainstream audience is to break it down into little pieces. Can I have a little more volume? Well, if we can have volume, it's okay. But part of visualizing this in an effective way is not only to create...
Throughout the ages.
Wow.
Some sections of the
not only to create the images, but also to make sure that they work in coordination with the voiceover, with the images that we are telling, so that the overall storytelling really has an impact on the viewer. This is stopping short. I don't know why this is stopping short. Let me just play one more time.
The fault reaches the surface at the feet of the Himalaya, 140 kilometers south of Mount
Something
Everest,
as simple as
and
maps,
continues deep under the mountains.
which most people think, oh, that's just a map, can be a really powerful way to tell a story and to explain things. And from a top view of a map, you can go to the cross-section, and you can go to the 3D view, and before you know it, people really understand how the earthquake happens, because they have a sense of place and physicality that's very important to understanding these concepts.
And we can see terraces.
We also use very simple visualization tricks such as this, which is really emphasizing the physicality of scientific explanations when scientists are on the field. So we do a lot of overlays, which really has to do with heads-up display concepts. But we don't look at it from the technology point of view. You don't need a hollow deck to do this. You can just watch a film, but it's the same concept. It's a heads-up display. It's overlays that explain to you what what she's talking about, what the scientist Judith is
The
talking about.
EnviroVibe truck
This is a highly technical machine, and we also tried to explain how it works in under 30 seconds to somebody who's never seen this before.
Ground vibrations after they pass through the subsurface and bounce back to the top. Data is collected by the DAC link and sent to the main computer for processing via Wi-Fi.
So the challenge when we create these diagrams is not only to come up with an artistic style that's within our budget and that's easy to understand, but also that can be seen clearly on a handphone, because we realize that most of our viewers are viewing our stuff on handphones or tablets, but really for the most part phones. So the type has to be a certain size, the contrast with the color of the background, all these technical artistic things have to be there or it's not going to work.
It vibrates the ground between 10 to 300 pulses per
And
second.
then I like this a lot, and scientists also liked it a lot, because we took the scientific data that the truck actually generates and made a very simple animation. I'll play it again, I hope it works. Sorry. Made a very simple animation that shows the viewers the actual, what's the next one? The actual scientific data, unfiltered, unretouched, but in a context that they can understand it. And this to me is a really successful example of visualization. Scientists get something out of it because they understand what those waves mean, but the general audience also gets something out of it. They understand that the vibrations of the truck are creating ways that can be translated into images that give us information about the underground. We are working on this movie that's basically about people who survived the tsunami, the 2004 tsunami in Banda Aceh. And the challenge in making this movie, on top of the fact that it's a very heavy subject and it's challenging to combine scientific explanations with very emotional testimonies of people. The challenge is, one of the biggest challenges is that there's very little footage of the actual event. Unlike the Tohoku tsunami in Japan, where there's hundreds of hours and helicopters and everybody was recording it on their phone, in 2004 in Banda Aceh, very little footage. So we had to create a lot of our B-roll. And so we chose to do some pretty unusual things, such as do these very stylized artistic views of a kampong that's actually destroyed when the tsunami comes in. Very cinematic style, very stylized. So I'm just showing you a tiny, tiny little clip. The movie hasn't come out, so we're not showing a lot, but it's going to be out by the end of this year. And hopefully we'll show it here at some point. That'll be kind of cool. So this is very simple. From the technical point of view, this is very simple, very relatively easy to produce. We're not trying to be hyper-realistic, but there's a simulation going on, and there's measurements, and there's data. So this is a totally different approach where we're trying to convey the emotions of people dying. And this is something that we really struggled a lot with, because how do you visualize human pain without getting too creepy or without getting too negative or down? So we created all these poetic sequences that hopefully help people understand what those who went through the tsunami and survived feel about the whole event. So of course here we represent the huge wave as a white line that's just kind of torturing this poor guy, and eventually, you know, he doesn't make it. This is just a little segment that I'm showing you. All right, we have a climate change project where we are really experimenting with all kinds of animation techniques. It's a lot of fun. I'm just going to show you a little bit. Sorry about that. You can see from the style point of view, it's a very limited animation, a little bit of anime flavor. a little bit of 8-bit game aesthetic, a little bit of painterly effects. So it's a combination of what we feel are cool styles that we can produce within our budget, within our time frames, and still come up with interesting stuff that hopefully is appealing to a wide audience. Not only to scientists who study climate change, but to kids, to older people, to adults, to people who care about climate, to people who don't care about climate. So these sequences that you're watching right now are obviously sequences about some of the things that we, human societies, are doing that impact climate. It has 6 parts. We're hoping to finish it in the next couple of months. That's our main project that we are working feverishly on right now. And I'm happy about it because with very limited animation, I believe we are able to convey quite a range of concepts. So that's that. Thank you for your attention. You can go to this website and check out what we do. And I guess the questions come later, right? All right. Thank you very much.
Thank you, Professor. And finally, our last speaker, we have Mr. Quah Chee Kwang. He's Principal Engineer at ST Electronics Training and